We want to review today. Tomorrow is going to be a quiz. I'll be gone, but you guys will have a quiz. And what we want to do is we just want to take a quick summary of force. Okay, and remember, forces cause acceleration. F equals ma is Newton's second law, and that means force causes acceleration. Remember, acceleration is speed up, slow down, or change direction. It's the rate of change of velocity. Force is not required to keep an object in motion. Forces change an object's motion. Okay, and what that means, if there is no acceleration, if there's no acceleration, then the net force equals 0. That's not the same thing as saying that there's no forces acting, right? Because friction is a force, and it always tries to slow things down. Friction always opposes motion, and it's a force. Friction is a force that opposes motion. So that's why we always have to pay attention when we are drawing our diagrams, that we actually know which way friction is going, what it's doing, because generally speaking we want to have the net force in some direction be 0, or we know an acceleration. So when we have like a box sitting here and somebody's applying a force this way, so somebody's pulling it this way, friction automatically says, well, I'm going to pull back this way. And if it's not moving, then this is static friction, right? Static acts between objects at rest, okay? Acts between surfaces at rest relative to each other. Okay, so if you're trying to start something moving, that's static friction. If something is moving on the back of a pickup bed, or say, you don't want the object sliding around the pickup bed, it's static friction even though the object is in motion, because it's not moving relative to what it's sitting on. Okay, so there's the pull force, there's static friction, and of course there's also gravity, and the force that opposes gravity and acts perpendicular to the surface, which is the normal force. Okay, all these forces are related, but remember, vectors are forces, or forces are vectors. Vectors only add if they are in the same or opposite directions. Okay, and if they're in opposite directions, then of course you subtract them. Now, what this means is we try to find things that are all in X or all in Y, and when they're not, we break them down into components. Okay, so let's take a look at just a simple problem like that. Okay, we have a box, okay, but somebody applies a force this way. Okay, we want to label all our forces and then see what we can do with that. Okay, so again, gravity pulls down. The normal force pushes back up. The normal force is always perpendicular to the surface. We should remember that, right? Normal force is perpendicular to the surface that exerts it. Okay? And so if the surface is horizontal, the normal force is straight up. But if the surface is at an angle, then the normal force is also at an angle. Okay, so there's normal force, there's gravity. Okay, the object is trying to be pulled this way, so this is the force that's applied. I'm going to call it F pulling force. And then there's always friction, okay, unless the problem says we can ignore it. Okay, and I don't know if this is in motion or if this is trying to be in motion, so I'm just going to call it FF for the frictional force. Okay, what can I say about this? Well, if we go in the X direction, the net force in X is equal to, well, if I look, this pull force right here, okay, it's got multiple components. It's pulling up and right. Okay, it's pulling this way, and it's pulling this way. Okay, I'm going to redraw that triangle down here. You've got the pull force, but it's not pulling in X or Y, it's pulling in X and Y. Okay, so some of it is forward, but some of it is also up. Okay, this is the X component, this is the Y component, this is the angle theta. Okay, well that means in the X direction I can say the net force is F pull X, so F pull in the X direction minus the frictional force, and that's mass times acceleration, right? Net force means the sum of all the forces, and Newton's second law says that's equal to mass times acceleration. Okay, and because we know some trig, we can say that X Well, this is the adjacent side to the angle, so the cosine of the angle is equal to adjacent over hypotenuse, but that means the x side, f pole in x, is just multiply this over f pole x cosine theta, right? So f pole x, or f pole, right, because it's not an x, it's the hypotenuse, f pole cosine theta minus ff equals ma. Okay, and in the y direction, the net force in y, okay, if we take a look, okay, we also have this force and this force and this force. So there's three forces in y. It's easy to forget that force from the pulling force, but it is there. Okay, and so I'm going to have the normal force plus F pole in y minus mg, the force due to gravity, equals ma. And from that I can say, okay, well, F pole in y, that's going to be the opposite side, so instead of cosine I use sine. So this is really the normal force plus F pole sine theta equals minus mg equals ma. Okay, so you got to just keep track of your forces in x and y. That's not what I wanted to do. The last kind of thing to look at here is what happens on an angle. Okay, and it's not new or different. It's just, okay, make sure that you remember to keep your forces pulling in the correct directions. Okay, gravity always pulls down. The normal force does not always push up. The normal force is always perpendicular to the surface that exerts it. Okay, it does generally try to balance the forces in the y direction. Of course, the y direction is changeable. I just picked x and y to be like this. So I still have the same equation. The net force in x is equal to, and the net force in y is equal to. And the difference is my x and y are tilted, right? This angle down here and this angle up here are the same angle. So when you have the incline, okay, you know the angle between the hypotenuse and the y direction of gravity, or gravity there. So this is FGY and this is FGX. Okay, so if I look at the net force in the x direction, and these are the only forces acting, then I know friction has to be up the incline because gravity is trying to pull it down. So there's some friction. So the net force in the x direction equals FGX minus Fs, which equals ma, Newton's second law. Net force in y direction is equal to the normal force minus Fgy, right, because I've got this one and this one in the x direction, or y direction, which equals ma, and this should probably be 0 because it's not going to jump up off the ramp or fall through it. Okay, and then you can go in and you can find your adjacent side and your opposite side and use trig. Okay, it's just a matter of getting all your forces to add up and using what you know to do that. Okay, so what I want you guys to do today is I want you to work a few problems out of the book. Okay, I want you to do number 95, number 101, 104, 106, 108. Okay, and I will post solutions to these later. And after you tried them, I want you to go through and make sure you did them all right. And if you have questions, by all means, email me.